in the presentation, namely the nature of the problem and some idea of what we've done to tackle the problem. Now, Sheila mentioned chess. Chess is a natural comparison for Watson. And I'll say a couple of things about the comparison. Performance at chess has always been the iconic representation of human intelligence. Language, on the other hand, has been the iconic representation of what it takes to be human. So in some sense, they share some kind of common distinction. However, the techniques, the algorithms, data structures, everything that's necessary to solve the problem of Jeopardy, to answer questions in natural language, is quite distinct. They're quite distinct from what was necessary to play chess. There is some small amount of game playing skills involved in the strategy part of the equation, but as far as question answering goes, it's a natural language understanding problem. And I have a few slides to illustrate the nature of the problem. And the reason for dwelling on it is that for humans, natural language understanding is a given. It's natural. And when we see a question, we dwell on the question. But for Watson, the challenge is understanding the language. Having done that, the question answering sort of falls into place. So let's take a question like this. Where was Einstein born? If you have a database, such as illustrated here, where the person is Einstein, the location of birth is Ulm, it's very easy to imagine how a computer can answer that question. But suppose you don't have a database, but you find a passage like this. One day, from amongst his city views of Ulm, Otto chose a watercolor to send to Albert Einstein as a remembrance of Einstein's birthplace. Now granted, this is maybe more metaphorical, more elliptical, more complicated than a typical paragraph, but this does illustrate how you really have to understand language to be able to pull out the fact that this is telling you that Einstein was born in Ulm. A similar example comes with this. What did Jack Welch run? You can imagine a database with people and the organizations that they run. Again, if that's what you've got, you look it up, you get GE. But if you find this passage, and in both these cases, these are actual passages that we have found in the corpora that Watson has at his disposal, it's not so easy. If leadership is an art, then surely Jack Welch has proved himself a master painter during his tenure at GE. I mean, someone who wasn't very sophisticated might think that Jack Welch was an artist reading this. I mean, it's a challenge to pull out of this that this means that Jack Welch was the head of GE. So let's look at what the Jeopardy challenge entails. It entails 5 dimensions of performance that a system such as Watson has to deal with. It's a broad or open domain. There are closed domain question answering systems, and they are easier to build because the vocabulary is restricted, often the terminology, the phrasing is restricted. It's much less of a natural language challenge. But with a broad open domain, the language could be just about anything that you might use, and the subject matter could be just about anything. Watson needs high precision. Unlike the typical case of when you do a web search and you're satisfied if on the first page that comes back to you, one of the documents happens to contain the answer to your question, if you use a web search engine for a kind of question answering task, that's not sufficient for Watson. It's not a document that Watson needs to return, it's an answer. And it has to be the top answer. You only get one shot at it typically. And the confidence has to be, Watson has to have confidence that this is the right answer, because in a situation such as Jeopardy, as well as some real life situations, there's a downside to giving the wrong answer. In Jeopardy, you're penalized by the amount of the clue. So Watson has to have a confidence, not only have to determine what the top answer is, but whether it's confident enough to buzz. Because of, as I said, the downside if you get it wrong. And of course, speed. The game is all about speed as well as question answering. And Watson is going against some really experienced players who are very fast and very knowledgeable. So take a look at these questions here. These by no means cover the whole space of language and questions, but they illustrate different aspects of the difficulty of the task. Let's take the first one. If you're standing, it's the direction you should look to check out the wainscoting. Okay, so that's a difficult word. If you replace it by floor, it's just as difficult for Watson to answer that. It doesn't have a list of directions. It doesn't necessarily know what directions are, north, south, east, west, or the kinds of things that a director gives to actors. Let's say there are lots of different meanings of direction. A child could answer that, though, because a child's situated in the world and knows that the floor is down. Watson doesn't know that. It's typically not written anywhere because it's the kind of thing that everybody knows. The question below it, cell division, mitosis splits the nucleus, and cytokinesis splits this liquid, cushioning the nucleus. Anybody know the answer? Cytoplasm. But if you look at the question, you see there's more than just a question in there. There's a fact that's given up front that's not necessary for answering the question. It's just some kind of a contrast that's given. In fact, Jeopardy wants the clues to be entertaining and informative, as well as to pose a question, a challenge for the answer. And there's that last bit, after splits this liquid, which is really the question part, there's the cushioning the nucleus, which is just thrown in to relate it to the first part of the question, which is unnecessary. So you've got a question in there, but it's embedded in a context of stuff that's not really necessary for answering the question. The third example there of the 4 countries in the world that the US does not have diplomatic relations with, the one that's farthest north, anyone? North Korea is right. But this is not an intrinsic property of North Korea. It happens to be a property of North Korea relative to the countries that at this particular moment in time the US does not have diplomatic relations with. If the US decided not to have diplomatic relations with Greenland or something like that, it would change that. So it's not a property of North Korea, so you can't get the answer so directly. So you look at this question and see you've got a question inside of a question. There's a nested question in there. There's the inside question, which is, let's figure out what those 4 countries are, and then what's the farthest north of those. So there's some really complex processing that has to be done. Let me start with the set of dots at the top. This is a graph that maps along the x-axis. You're thinking you're back in school now in geometry or algebra. The x-axis is the percentage of questions answered. And we have plotted the performance of previous Jeopardy winners on this chart. So the x-axis that goes from left to right is the percentage of questions they answered when they were on their show. The y-axis, going up and down, is when they answered, how many of them did they get right? So that whole cloud that we call it, the winner's cloud, at the top of that graph, each dot represents a single instance of a Jeopardy winner. And you see, for the most part, they answered about 50% of them. 50% of the questions. Now, on average, because there are 3 players playing the game, each player should get 33 1/3%. So a winner, on average, gets 50% of the questions. And when they buzz in on 50%, they get somewhere around 90% correct. The dots that correspond to Ken Jennings are colored red. So you'll see that he answered on average about 70% of the questions, in some cases over 80%. And he got most of them right too. So that's the challenge we're up against. 4 years ago, we had a state-of-the-art computer system. And when we plotted that on this graph, it's the line at the bottom in brown. Why is it a line rather than a dot? It's because you've got a degree of freedom. You can choose how risky you want to play. You want to try and answer all questions, in which case you're going to get a lot more wrong, or just answer those where you're more confident you'll get more right, but you won't be going for so many. So that's the left-hand part. So when you've got a computer system, you can change your risk aversion parameter and you get a whole line. So you can see we had a long way to go. I'm going to come back to this chart in a minute. I'm not going to go into this in gory detail because that would take hours. But the takeaway from this is that there are a lot of components in the system. We start on the left, question comes in, it undergoes question analysis, so some aspects of the question are determined by some algorithms. A search is done. You can think of it similar to the search that your favorite web search engine does. And documents and passages come back. And then those are analyzed. And a number of candidate answers are pulled out of that. So there may be 100 or 200 candidates that it has in hand that it wants to process further. And then it runs a number of algorithms, again between 1 and 200 algorithms, to look for different characteristics and features of each of those candidates. And that's illustrated by this fanning out there. So in the end, you have lots and lots of numbers. Each candidate answer has lots and lots of numbers representing its worth along these different dimensions. Then we apply a machine learning algorithm which is determined how to weigh those different characteristics and features, which ones are the more important ones. And then all those numbers are brought together to give a final confidence score. And so all the candidates are now put in a ranked list, and the one at the top is the answer it wants to give. But it will only give it if its confidence is above a threshold. This is just an illustration of how some of these features may play out in a given question. The question here is Chile shares its longest land border with this country. Now, the answer is Argentina, but Bolivia was a strong contender. Why was that? It's just because some of the features favored Bolivia. Some of them favored Argentina. There happened to be a border dispute between the countries, which meant there was a lot written about the land border between the two. So it turns out when we ran on this question, Argentina did win, but Bolivia was very, very close behind. So it really all depends on how the different components of evidence stack up against each other and what the totality is of the evidence for one candidate or another. The machine learning algorithm that I just mentioned, where it determines how important to consider the different features, showed us some interesting things. In particular, it showed us that the category is not very reliable for determining what the type of the answer is. So here are 6 examples where, given the category, US cities or country clubs or authors, the answer was not a US city or country club or an author. That was the theme of the clue, yes, but it wasn't the type of the answer. So there's no guarantee that the answer type is the same as the type of the category. Did any of you see the game yesterday?
Yes.
What happened yesterday in Final Jeopardy was the category we knew at US cities, but the answer that Watson gave was Toronto, because it had learned, in general, it happened not to be good for this particular question, but in general, the category is not a reliable determiner of the type of the answer. So it didn't put too much weight into whether Toronto was or was not a US city. It so happens that there was some evidence for Toronto, because there are Torontos in the US. The Toronto Blue Jays play for the American League. Toronto is known as an American-style city, and so on. So there was a small amount of evidence. So the real question to ask is, why did Chicago get a better score? Not why did Toronto get some score? So similar to that picture I showed you of Argentina against Bolivia, there was a trade-off of Toronto against Chicago. And the complexity of the language in that question just defeated it, and it was not able to get good evidence for Chicago. The Toronto confidence was very, very low, which any of you who are eagle-eyed would have noticed there were a lot of question marks put after that answer. That's what Watson does when it really doesn't know, but it's forced to answer. By the way, the middle category there, I'll point that out, says country clubs, but as is their wont, they were punning. The answers are weapons, clubs, used in different countries. Another reason why not necessarily to read too much into the category. Now, remember that chart I showed you a few minutes ago? What I've added to this chart is the performance of Watson as measured at intervals during the last few years. And you'll see its progression from being in December of 2007. There's that orange line, which is considerably better than the first system.